I would actually download Notability. So this is Notability right here. So that's the other thing you guys could actually do, especially for A&P. I would download the PDFs right in here. See that thing with the four-corner star? Yeah. If you click on that, that's if you pay for a subscription. If you click on that, it's AI. It would take all of your slides, and it gives you a summary of everything. And you can say, make a quiz. It'll create a 10-question quiz. You answer the questions. And then you can say, and it'll tell you what's right, what's wrong. And then you can say, create another quiz. So it'll generate a quiz. I think it was like, was it $7 a year? $8 a year? No. It's like $8 a year. So that would be like the Notebook LM. But Notebook LM is also free, right? So yeah, I mean, those are the things that I would do myself. And it's harder with math with Notability because the question is more about the concepts than about problems. Yeah. So it's not going to create any problems for you to do, but it's going to create concepts. So for A&P, bio, nursing, those type of stuff, it's great. It's like, because it's going to ask you those type of questions that you need to know, right? So yeah, I think Notability their AI is definitely better than GoodNotes AI right now. I'm not saying in the future it's going to be better or worse, but right now it's way better. Well, actually, you know what I do? I just do it as an open box at Best Buy because that's like 20% off of the original price. So what people tend to do is they'll buy this pencil because it looks better. But the problem is that but they bought them a regular iPad that doesn't use this pencil. So now they got to return it. So it's now an open box, so they have to sell it for 20% cheaper. So you just go in and you buy it for 20% cheaper.
I thought I lost this one, so I bought a new one. It turns out it doesn't work with my iPad. So it was engraved Apple Pencil that I could never use.
Yep, that's why I always go open box. Yep. And if I was to tell you if you already have an iPad, you definitely need to know the generation. If you are buying a new iPad, because for some reason, like iPads right now are actually, iPads and MacBook Pros are actually, and MacBook Airs are actually getting cheaper. So if you don't want to spend the money on iPad Pro, then iPad Air should be your next choice before the iPad. iPad is the one that kind of gets out of date very quickly. The iPad Pro, they essentially put everything that they know in there. So it takes the longest to go out of date. iPad Air is somewhere in between. So it takes longer to be out of date. But iPad, oh, yeah. But that's a Pro though.
I got this in 2023. And I think it was 800. And then I bought myself a MacBook because I didn't like just having an iPad.
It's always one that feeds into the other. It's like a drug.
Now I use my MacBook more than my iPad, so I'm fine with my purchase.
Yeah.
But I felt bad because I didn't use this for like a year after I got my MacBook.
But now that you see me using it all the time.
Well, she got me back. I always like to use GoodNotes, but she got me. She was like, do the lab work on your iPad and see how you like it. I was like, okay. It's actually really nice because you can like lasso this stuff and move it. And
Mm-hmm. Yes, right. And there's a lot of students that because I use an iPad, they start using. So, all right, ladies and gentlemen, let's get started. The recording has been going. So you guys, your first 5 minutes is going to just be speaking of nonsense. All right, so let's finish the notes from last time. The thing that we're missing is what we call a rational equations. So these are equations that have fractions in them. Okay? Did we? No? Okay.
Square root. This is my last.
And raised to the 1/2 power thing?
No, square root. The radical one.
Yeah, we did the 1/2 power as well. The sun and the grass. All right, so let's say, for example, I have 4x over x minus 2 minus 8 over x plus 2 is equal to 32 over x squared minus 4. Do you guys remember what's the first thing we should do? What's the first thing we should do? Even before that. Before that. Even before that.
Get rid of the square root or the second power.
How do we do that?
Divide.
Don't do that. 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 Oh, factor everything.
X plus 2, x minus 2.
Ah, the difference of two squares. Wait, I heard those words before. Where did I? Oh, that's from the last class. When we talked about quadratics, right? The difference. Oh boy.
I'm fried. My brain's fried. Don't ask me questions.
Right? Two terms, difference of two squares. So we have heard that before. Even scrambled brain remember hearing those. So this is going to be x minus 2, x plus 2. And then we're going to put other binomials in parentheses for that reason. After we factor everything, then we want to find common denominators. Okay? So here's the thing, guys. There is a gazillion ways that you can solve this. When I teach this, I like to teach one way to kind of take care of a bunch of things, right? So over here, if you look on the left side, that's adding, subtracting fractions. Adding, subtracting fractions, we need common denominators, right? So I like to use common denominators rather than using LCDs, okay? What do I mean by common denominator? Meaning I want the denominators to look exactly the same. So what I have to do, and the way I explain this is because I have 3 fractions, so let's say I got triplet girls, okay? Poor dad. Triplet girls, and let's say those triplet girls happen to be spoiled. So I'm not saying all triplet girls are spoiled, but let's say these triplet girls happen to be spoiled. And when they're spoiled, what they do is go, Daddy, Daddy, you love her more than I. Like, why? Because she has this, I don't have this, right? And of course, it's not just from one, all 3 do the same thing, just at separate times. So Dad goes like, okay, enough. I love you all the same. So what I want you to do is I want you to write down what the other ones have that you don't have, and I'll just buy everybody missing pieces and so that everybody has the same thing. All right? So this sister here, oh, wait a minute, don't forget the hair. She's looking and saying, okay, what do they have that I don't have? So what is she missing? Awesome. If I do that to the bottom, I have to do it to the top. Awesome. So now let's go to this sister. What do they have that she doesn't have? If I do it to the bottom, I have to. Awesome. And this sister here go, ooh, uh-oh, I do have everything. All right, bye-bye. Right? So now if we were to look at the denominator, is this denominator the same as this denominator? The same as this denominator? Yes, yes, and yes, right? If the denominator is all the same and it's an equation, then I can write just the numerator as my equation. Okay? Does anybody ever wonder, why can I just get rid of the denominator? Can I just toss that? Why can I just toss it out?
Because they're all the same.
Because the denominator is all the same. And plus, if you are wondering, I usually use this sidebar right here. I go, okay, if I said x over 5 is equal to 2 over 5, you're going to tell me what? X is equal to 2, right? Because the denominator is the same, that means that must be my equation, which you just said to me, x equals 2. Same exact idea. Okay? Now, notice that I didn't distribute anything. I just rewrote the equation. And the reason why I do that is because the mistake that people make is that they miss out on this negative sign. They will try to distribute this 8 through, not realizing that they are supposed to distribute the negative 8. But if I rewrite, then it's pretty obvious I'm distributing negative 8. Okay? So let's solve this. 4x squared plus 8x minus 8x plus 16 equals 32. So there's two ways of solving this. One is, I see a square term and an equal sign. What should I be thinking of? Quadratic equations. So get everything to one side. That's one way. So I could go in this fashion. Or I could go with the square root property, right? So plus 8x minus 8x goes to 0. Subtract the 32 over. 16 minus 32 is negative 16. Okay? So this way you don't have to go, WTF did that come from? Right? What's the matter?
I missed that.
Where'd you mess up?
So, what, 4x squared, 8x cancels out, plus 16
Is that true?
minus
Okay, subtract the 32.
16.
Would be, yep. Wouldn't that be negative 16?
Wouldn't it be positive? 32 minus 16 is positive.
You mean 16 minus 32, right?
Oh, okay. Sorry, I'm thinking to get like the without the variables on the other side.
And you could solve it that way because that would be just the square root property, right? You'll have x squared equals to 16. I'm sorry, x squared equals to 4. It would be plus or minus 2. But in this case, I could do this. I could factor. Right? And then divide by 4, and then take the square root property, plus or minus 2. This is the difference of two squares, which is part of factoring. So remember, in factoring, we have 4 terms, which is factored by grouping, 3 terms, AC method, 2 terms, difference of two squares. So the question is it a subtraction? Yes. Is this a perfect square? Yes. What times what gives you x squared? What times what gives you 4? Plus minus. Remember that? Okay. So here's my question. Can I use these two answers? ¿Por qué? Oh, ¿por qué? Why are they rejected? So with rational or with fraction, there's an issue. The issue is this. If you took 4 divided by 0, what do you get? Okay, everybody, take your calculator, go 4 divided by 0. See what you get. Doesn't your calculator just flip you off? Try it. It doesn't really flip you off, no. But it would be funny if you did, right? You did something dumb on your calculator, it just flips you off. That'd be awesome. I would actually like using a calculator. I'm like, all right, hey, let's see what else I can, what other dumb stuff I can put in, right? No, it's going to tell you it's an error, undefined, divide by 0 error, right? It's going to tell you those things. Because anything divided by 0 is actually undefined. Undefined means doesn't exist. So if this denominator was 0, that means this fraction is undefined. If this denominator was 0, that means this fraction is undefined. Well, if any of these fractions were undefined, that means this equation doesn't even exist. Make sense? Okay? So the problem is that, well, if I put 2 in here, what will happen? The number was 0. If I put negative 2 in here, what happens? It makes a 0. That's the reason why I would have to reject anything that gave me a 2 or a negative 2, which is the answer I got. That's why I have to reject both of them. So since the answer I got here is 2 and negative 2, I have to reject both. And since those are only 2 answers you gave me, then I have no solution. Apparently that makes an arrow. Right? So with rational equations, we always want to make sure we check our restrictions. Check the restrictions and say, okay, what can I not have? Any questions on that? Are we okay? Yeah? All right. So for the next part, I'm going to talk about system of equations. All right, so the word system only means more than one. So system of equations is just saying there's more than one equation. That's it, okay? So you could, so one of the things that you first learn with system of equation is if it's more than one, then the smallest number would be 2, right? So let's look at what would happen if we only had 2 equations. So let's say we had 2 lines. What would happen there is that they would actually cross at a point, x comma y, which means that have a solution. Where they cross is your solution, right? Meaning, with the 2 equations of a line, if I solve for an x value, there has to be a corresponding y value. If I solve for a y value, there has to be a corresponding x value. Okay? But the question is, what happens if I have 2 lines like this? They never cross. That means I should not be able to find an x nor find a y. Okay. So if I don't find an x or a y, how the heck are we going to know? Well, number one, we know that this is no solution, right? Because they don't cross. But what the heck happens when that's the case? How am I going to know when there's no solution? Well, what's going to happen is that when you're trying to solve for x or y, both the x and y will disappear. All you have left is numbers. So you might get a statement like this, or a statement like this, right? What do you think about those statements? They're false, right? Neither one of them are true, so these are false statements. So you have false statements means no solution. Make sense? Okay? There's a third scenario. Scenario number 3 says, what if that happens? You're like, well, what's that? All right, let's make it this way and this way. So these two lines are on top of each other. So that means they're in constant contact. If they're in constant contact, that means there is infinite number of solutions. Which means that everything works. All reals. That's what that means. So how the heck are we going to know that? Well, the same thing actually happens. The x disappears, the y disappears, we're only left with numbers, but it's going to be something like this. And those are? So if we have a true statement, that means it's either infinite number of solutions or all reals. So notice that it's not only about equals. It can happen other places. It could happen with an inequality equation where the x and y disappears. So anytime your x and y disappears and you're only left with numbers, if you have a true statement, that means all reals. If you have a false statement, then there's no solution. Okay? So if the x and y disappears, it's one or the other. Are we okay so far? So here's the question. When we had two equations, oh, before I even go there. So equation of a line, any equation of a line usually has an x and a y in it, right? So typically, if we want to find values for those x and y's, then in order for me to have two unknowns and to find the value of those two unknowns, I would have to have two equations. So the number of knowns that we have is the number of equations we need to have in order for us to find values for those unknowns. Right? So two unknowns, x, y, I need two equations. If it's three unknowns, x, y, z, or a, b, c, then I would need three equations. For the ones that took intermediate algebra, we talked about two unknowns, two equations, two unknowns before, right? Do you guys remember what methods we use for those two equations? Awesome. So we use the two methods. One is called come on, box. Make a box. So the first was substitution. The other is called elimination. Now, the elimination also has another name for it. So I'm going to go ahead and not review those. But you're like, but wait, we didn't remember. The reason why I'm not going to review it right now is because I'm going to jump into three equations, three unknowns. And we're going to have to hit two equations, two unknowns anyways. Then I'll talk about these two. All right? Is that fair? All right. So stalling. So let's say, so we're going to go with three equations, three unknowns. Should I start a new page? Nah, let's just keep on going. So let's go with three equations with three unknowns. So let's see here for this example. 2x plus 3y plus z equals -5. 3x minus 4y minus z equals 22. 5x plus y plus 3z equals -2. So clearly 3 equations, clearly 3 unknowns, x, y, and z. So the first thing I want to bring up is that notice that these 3 equations are all in standard form. What do I mean by standard form? Meaning all the variables is on the left side, all the constants is on the right side. Okay? All the variables on the left side, all the constants on the right side. So if you guys ever have an issue, I'm going to tell you, you might want to put it in standard form. It makes things a lot easier to look at. I promise you that. Okay? Sorry for boring you. So the way we look at this is this. So if you keep this thought, then everything else is going to be easier, because this would be, quote unquote, the hardest there is. The problem is that when you guys look at the other problems, you're going to think it's harder because it looks different. Huh? It's not in order, or something is missing and you're like, oh my goodness, it looks different. It must be harder. How do we do this? Okay? But if you keep in mind that we're starting off here with 3 unknowns, 3 equations. We're trying to get to 2 equations, 2 unknowns, so that we can get to 1 known. Then we're going to work back up to now 2 knowns, then work all the way back up to all 3 knowns. So literally it's working down and working back up. That's what it is. So if you keep that in mind, that's what I want you to think of. All right? So number 1, standard form. Next, I'm going to name these 3 equations, or number these 3 equations. 1, 2, 3. Okay? So I'm going to number those 3 equations. Notice I have all the x's lined up, all the y's lined up, all the z's lined up, right? Okay. So from there, I want you to pick 2 pairs. Okay? So you could pick 1, 2, with 2, 3. You could pick 1, 2 with 1, 3. Or you can pick 1, 3 with 2, 3. I believe those are only 3 pairs you can really pick from. So you want to pick 2 pairs. Okay? Out of my iPad laziness, I would do that. 1, 2, 2, 3. Because I can just duplicate and paste. Why wouldn't I do that? You're like, I got to write all that down? You mean I can't just go paste? Dang it. Go ahead and do that. I'll give you some time while I chew on my bagel. A lot easier on an iPad, isn't it? And you made the realization already that nobody else is realizing yet. Eventually they'll figure it out.
Well, I want to hear I'm assuming this one isn't going to be picked to be created.
I don't know.
Oh, that's your turn.
Mm-hmm.
So I kind of looked at my direction a little bit ago, but I just don't know in the right direction. I'm kind of confused on the last part.
Mm-hmm.
I picked two, then I used that solution, and then I picked the other two, and then I got these to get an equation from the equations together.
Mm-hmm.
And
Mm-hmm.
then I got x3
Mm-hmm.
to
Mm-hmm. And then you plug it back over
with
one of these, one of the three. That's why I was like 3 to 2 to 1 to 2 to 3. Bring it in. All right. What program are you using? You're upside down. So you could use Freedom. You don't need to though. Where's your app store? I would use Notability. Notability, yeah. Log into the Florida Southwestern State College. Are we all caught up yet? No. Mm-hmm. Mm-hmm. Your username at bucks.fsw.edu and your portal password. All right. So let's look at the first pair. You need to pick a variable that you want to eliminate. So let's talk about elimination in general. Elimination is great because you get to choose what you want to eliminate. Right? You get to choose it. So what would you eliminate in these two equations? Z. Right? Because so once you choose what you want to eliminate, you want to make sure the coefficient is additive inverses of each other. What the heck does additive inverse mean? Same number, but one's positive, one's negative. In this case, one's already positive, one's already negative, right? So I just add them. I get 5x minus y equals 17. And I'm going to go ahead and call this, well, how about just call it 4. Since we have 1, 2, and 3 taken care of, let's start with 4. You got it down? So this is free unless you want the subscription. All right? So here's the thing. Once you decided that you're going to get rid of z, you have to do the same thing on the second pair. So whatever you decide to get rid of, you got to do the same thing there. So now I have to eliminate z. So what do I have to do to eliminate z here? Multiply the equation 2 by, so I got to multiply this by a 3. Do we understand why I have to multiply by 3? Here's the reason. Because remember what I said about elimination. We get to choose what we want to eliminate, right? So since we're choosing z, I need the coefficient to be the same but opposite sign. So I need this to be a -3. In order to get there, I have to multiply that by 3. So I want you guys to see this. Notice what I'm about to do. I'm putting a division here, or separation here. And I'm going to rewrite equation 2 after distributing the 3. So I'm going to get what? 9x minus 12y minus 3z equals 66. So let's add those. And let's call that equation let's not skip 5 now. Call that equation 5. So notice that I just went from 3 equations, 3 unknowns, down to 2 unknowns. Right? Start writing. So now I have equation 4 and I have equation 5. Okay? So, now the reason why I like this example is because it's a good example to review about substitution. So elimination we already kind of went through over. Is about what you pick to eliminate, right? Number 1, number 2. Then I want to make sure the coefficient is the same but opposite signs. Elimination. Substitution, however. So in this case, here, when I have 2 equations, 2 unknowns, I can again use elimination or substitution. So to do substitution, what I want to look for is a coefficient that is a 1 or a -1. Which I have one, right? Isn't this coefficient right here a -1? All right, so let's go ahead and get this y by itself. So here we go. This is going to be what? 5x minus 17 equals to y. Yes? Then I'm going to take that. No. So from here, I'm going to, the reason why I use arrows, guys, is to remind me that this equation that I just got came from the equation 4. I'm going to plug it into equation 5. Why? Because there are people that does this. They get that equation, and they go, okay, let's plug it right back into equation 4. If you're sitting there going, that doesn't make any sense. You're right, it doesn't make any sense because it doesn't, but people still do it, right? That's the reason why I question it. There we go. All right? So that's why I use arrows, so that I don't run into that situation. Okay, so let's go ahead and take this problem. Oh. So we're going to take that and plug in the equation 4. Replace the y. Is that enough space? Let's see. Let's just make sure. Replace the y with this. Boom. Right? That's what substitution is. We're solving for one variable, substituting into the other. Yes?
But you're doing the substitution method again?
Yeah.
I didn't follow it with the.
Elimination, that's certainly fine. I only did it with I only did the substitution because I hadn't talked about substitution. It's just to show. That's all. I would have done elimination as well. Which one? We just did it twice up top. We literally just did it twice. On 1, 2, and 3, and 2, 3. That's elimination.
So now we're solving.
Yep. So, again, guys, look at what just happened. 3 equation, 3 unknowns. 2 equation, 2 unknowns. Equation 4 and 5. X equals 3. Right? Now I should be able to get 2 knowns. How do I do that? How do I get the second known? Can I just do this? Right? So now I got So notice, when I went back up on the triangle, I'm literally going back up this problem. Right? I got the 3, then I'm looping back to equation 4 and 5. Then I'm going to loop back all the way up, as the song lyric says, right? All the way up to equation 1, 2, or 3. Which equation would you guys like to use? 1? Sounds good. I think that's why it's heard, but I have no idea. I'm assuming. There it is. X is 3, y is negative 2, z is equal to negative 5. Any issues? Not bad, right? It is. As someone would say, tedious. Right? Now imagine it was 4 equations, 4 unknowns. No, thank you? Okay. I don't blame you. Yeah, 6 minus 6 is 0. I swear it is. Look, 6 minus 6. 0.
My brain goes. I'm just tired. I was looking on Pearson. I was doing. I'm on 5.2 still. I saw there's ones with missing variables, so those are super confusing.
They're actually not. Okay, so first of all, let's answer this question first, okay? So let's say, so this answer, guys, here is going to be this. So it actually matters the order here, right? Because it's x comma y comma z. Okay? So let's say, for example, if we were just given these points, and it was to ask, hey, is this point right here a solution for these 3 equations? Okay? Let's say that. How would I show that that point is a solution for those 3 equations? Correct. Because I got x, y, z. I plug it into the first equation and see if the left side equals to the right side. If it's a yes, great. First part done. Then I got to do it to the second. In other words, I got to get a yes, yes, and yes in all 3. If it's a no in one of them, then it's not. Okay? So hopefully when you get the first 2 yeses, the third is a yes. Because you're like, dang it, right? So as long as one of them is a no, it's a no. Okay? So the next question is, hey, I'm in MLM, and the reason why I know this is because the last class asked the same question. So I said, okay, here, let's take this example and I do this. Okay? So you see something like this, right? So remember what I said. We got to look at this triangle. 3 equations, 3 unknowns, to 2 equations, 2 unknowns, to known, right? So in other words, I'm trying to get here from this. So here's my question. I want you to pick one of them as your equation 4. Because essentially when we get to 2 equations, 2 unknowns, we're looking for equation 4 and equation 5, right? So let's pick one of these as my equation 4. What would you like to pick as your equation 4? Nope, just one equation. One equation to be my equation 4.
3.
Okay, great. So you're picking this to be my equation 4. Okay? So this equation only has an x and a y in it. Is that right? Okay. That's true, yes? Okay. Here's my question. Do you think I can use these 2 equations and eliminate something so that I only have x and y in it? Bingo. There's my equation 5. Does that make sense? Yeah. Because remember, when I found my equation 4 and 5, equation 4 and equation 5 had the same 2 variables that were unknown. Is that true? So if I added these 2, I'll get 3x plus 3y equals 17. That'd be my equation 5. So let's go back. So the last class actually picked this one. I'm like, okay. So if we call this equation 4, this only has x and z in it. So that means I need another equation with x and z in it, right? Okay. Can these 2 equations get me x and z? Yeah, eliminate the y. So I'll multiply the equation 3 by -3. Eliminate the y. I'm left with an equation with x and z in it. So that's my equation 5. Everybody see that? You guys got to do it. That's the biggest part. If you chose this equation 1, let's say, right? This equation only has y and z in it. Okay, great. Let me move it down further. Can I use these 2 equations and only get, what was it? Y and z? I just have to eliminate this, right? Then I'll be left with y and z. -2. My z has a line through it.
I just get confused because if you can use the upper 2 equations, there's no z for the other ones.
Yes, there is.
5x plus y, only 1 is z.
Yeah, but again, if this was my equation 4, that means my equation 5 needs to have y and z in it. So can I take these 2 equations and eliminate x so I only have y and z in it? Yeah. Correct. The question is, can I use, yep, you're going to keep one and then use the other 2 so that the equation 5 is going to look exactly the same as the equation that you just picked. So it doesn't matter which one you pick, you just got to pick one. Okay? Because essentially, when I get to 4 and 5, I want to be 2 equations, 2 unknowns, same unknowns. That's the only thing. Cool? Any other questions so far? Nothing. Oh, you want a different problem? Sure, sounds good. Let's do that. Let's say it says write a quadratic equation, and it says y is equal to ax squared plus bx plus c. And then it gives you a table. You try to write? Well, at least practice writing. Because that's going to be the biggest part is practice writing. Because when you first start writing, it. Mm,
Oh, on the lab, there's something similar to this, but it doesn't have a table. It's got like points.
what's the difference?
Oh, you can just use them as like more.
Mm-hmm.
Okay.
Right? I
I
mean,
did it. No, I know how to do it, but yeah.
yeah. Makes sense though, right?
Yeah, it does.
So if this is the case, what should we do? Oh no, I haven't opened up the lab work yet. It's only funny because it's true. Ooh. So you're saying I should take each of these as separate points. And plug it in this. Oops. I don't need the y, do I? So the red point would be -5 equals a times -1 squared plus b times -1. 13 would equal to a2 squared plus b times 2. And 23, it would equal to a3 squared plus b3. That's what you're saying. Agreed. So what I have, -5 equals a minus b plus c. 13 is equal to 4a plus 2b plus c. And 23 is equal to 9a plus 3b plus c. That's true? Are we okay? So, as much as it's tough to set up this problem, why do I like these problems? Because no matter which pairs I pick, I can eliminate C. It's just so easy, right? So, number 1, let's label these. 1, 2, 3. Out of laziness, let's pick 1, 2. And 2, 3. All right. Let's see how well we do. Go for it. So you can always add different colors. Mm-hmm. Mm-hmm. And then you can write. Yep. Go. Get out of here. Have a good weekend. Everything good with you?
Everything good.
Good. I was concerned. I was concerned last semester. Remember, in order to add them together, you gotta negate all of these, right? Because that has to be the same, has to be opposite signs. So you gotta multiply everything by -1, right? So that means you have 18 instead of that. See how the writing is a little like,
Yes.
and you can put your heel of your hand on the screen.
Like this, yeah.
Yep.
Put it like that.
Yep, you can. So that's gonna make it easier than trying to write it without anything on there, you know? Yeah. And so with yours, right now you have it set where how hard you press is how thick the line is,
Okay.
right? So if the layer you press is this, the harder you press is like that. And that is in your settings to make that
Smaller.
different. Yeah, like just have it consistent. Because the only reason why you want it to have that pressure is if like you're drawing, right? You want a thicker line versus like a brush would be lighter versus heavier. Did we get that for equation 4? Yes, ma'am. Are you wondering what the heck did I do? Okay. If you get -18, it should be -3a and -3b. Yeah, because if you multiply like this by negative, yep, that's why you get -18, but then this would be -4 plus, right? Huh? Yeah! Do I look like a half R's kind of guy? No, not at all. Now I have two equations, two unknowns, so either elimination or substitution. You're welcome to use substitution, but you can just use elimination. So if you look at these two, which one do you want to eliminate?
Like the variable?
Yep, which variable do you want to eliminate, A or B? Okay, so that means the coefficient has to be the same coefficient but opposite signs. So what do I then multiply this by so it is that way? -3. Because they're on opposite sides. Right? Make sense? My question is, would you accept that excuse from anybody else? If you wouldn't accept it from anybody else, why would you accept it from yourself? Yes, no? Gamse, gase. Mm. How do we do? Holding on. What happened? Okay, so here's the thing, guys. You're right, though. Right? One bit off. One little distraction. Meaning, while you're doing this, if you did one thing wrong, everything else goes wrong. Right? So one distraction. Oh, I got to check who just... Now you just got thrown off, and everything goes back downhill. Right? Everything else goes poopy. So we got to be careful with that. I'm sorry. No. Someone just hiccuped. So remember that the question was asking for you to write a quadratic equation, meaning I got to replace the A with A, the B with B, the C with C. A was equal to 1, so that's why I didn't write it there. B was equal to 5, and C was equal to negative 1. So that's why. So remember the answer for the XYZ was different from the ABC. So when you guys are doing these type problems, guys, you kind of have to make sure that you start, you finish. Right? So if mama tells you to go and set up the table for dinner, just say, please give me 1 more minute. Right? Get it done, and then go set up the table. Right? Because if you go set up the table, you come back, you're like, oh crap, where did I end up? Where did I just stop? Right? Where was my mind? And that's hard to do. So you got to make sure you finish. Any other questions? Isn't it? You're talking about my writing, right?
No, I'm talking about I figured it out and I didn't have to
See? Any other questions? So any questions on the lab work? Huh?
1 and 2.
1 is actually,
I think I got 1, but
1 should be pretty easy.
2 I'm confused on how to start.
Okay. Okay, let's talk about number 2. So what is the first thing I talked to you guys about in terms of word problems? Huh? No. You're not Simon. You're not Simon. It's Saturday Night Live. I know my name is Simon. I like to do drawings. All right, so do you guys remember back in English, you guys would have to read a passage and answer questions? Yes? So here's the thing. I wish I knew this information when I was a student. So if I tell you how I did those passages, you'd be like, dude, what the? It doesn't make sense. So when I do the passage reading and answer questions, I literally read the first sentence, and then I go back down and I see if they answered any questions. Then I read the second sentence. Did I answer any questions? Read the third sentence. Did I answer any questions? Then I thought, what did I read for the first sentence again? So I got to go back to the first sentence and go, did I answer any questions? So literally that's what I would do. But that's what a math brain does. So for you guys got to flip the switch a little bit. Meaning, you're trying to read this as a passage. So you're trying to read the whole thing and then say, what's the answer? It doesn't work. Just like reading the passage one sentence at a time to see if I answer any questions, doesn't work either. Right? Because you'll be like, that doesn't make any sense. Why would you do that? Why didn't you just read the passage? And that's the reason why. Okay? So let's do this. All right. The number of centimeters, d, that a spring is compressed from its natural uncompressed position. Okay. So what does d represent? The spring, or is the spring compressed, and it is in what measurement? In centimeters. Awesome. It's given by the formula, this, right? All right. Next part. Where W is the number of joules of work done to move the spring. Okay. What's W? Work. And the thing is joules. Awesome. And then we have K, the spring constant. So notice that I only read little fragments, right? And wrote something down. Little fragments, wrote something down. I didn't read the whole thing and say, okay, give me everything. You'd be like, I don't know what to give you. There's so much. So that's why I'm reading little fragments and then writing something down. Okay. So remember, this is two parts here. And I'm going to ignore the first part, and I'll explain why soon enough. It says solve this equation for W. Meaning I'm supposed to solve this equation and get W by itself. Some of you guys can do it. Some of you guys are going, there's too many letters. I don't know what to do. True? Okay. All right, so let's ignore that part for now. And what we're going to do is we're going to go ahead and use the result. Actually, we're not going to use the result. What am I talking about? To determine the work needed for the spring to move, work needed to move the spring 2 centimeters if the spring constant of 0.4. Okay, so where does the 2 belong? Right? So yesterday someone goes, is it K? And I said, wait a minute, it says 2 centimeters. Which one of those says centimeters? Only the d does, right? So the d is 2 centimeters. The 0.4 must be what? The constant. That's right. So, here's the thing. Or I should say, for the students that can't solve for W here, let's do this. Let's put the numbers in. Okay? So let's say two is equal to 2W over 0.4. Is that right? Okay. So, because there's so many letters, now there's only one letter, right? I'm solving for W. Great. What kind of equation is this? Have we talked about this type of equation? What kind of equation is it? With a D. A radical equation, right? So with a radical equation, what's usually our first step with radical equations? Before that, we have to first isolate the radical. Then we get rid of the radical, right? Because if you look back in the note, the first thing we did was isolate, get the radical by itself, and then we raise it to, we square it, right? Everybody agree? We okay? So let's go ahead and square both sides. So I'm going to square this side. If I square this side, I have to square the other side, right? Okay. So you're telling me that 4 is equal to this fraction right here. Agreed? What would you do next? Awesome. So you want me to multiply this side by 0.4. So if I do it to this side, I have to. Awesome. Everybody agree? Okay so far? All right. So I got 2W is equal to 1.6. What do I do next? Okay. So W is going to equal to 0.8. Was that hard to do?
Do you want it in 0.8 or do you want it as 4.5 or 4 over 5?
In this case, 0.8. Does it ask for a fraction? No, because given the fact that the constant is decimal, I'll probably leave it as decimal. All right, so here's the thing, though, ladies and gentlemen. Remember the part that we ignored. We're supposed to take this equation and solve for W. Right? Guess what? What I just did on the right side, I'm going to use those steps exactly as is. Because there's no difference. Okay. Let's look at the right side. What did I do first? Which we square both sides. So we square this side. So we had to square this side, right? Okay. That's exactly the same step, right? I didn't do anything different. So you're telling me that d squared is equal to this right here. Agreed? What did I do in this step? So you're telling me that kd squared is equal to 2w. What did I do next? So you're telling me that w So here's my question. Was that hard to do? Especially if I did this, right? Okay, so for the problem, I did step 2 before step 1. But if step 2 helps you with step 1, why not? You still did it. Because this is supposed to be step 1. Now here's the thing. If you plug those numbers in here, you're still going to get 0.8. Okay? Now, let's say it doesn't give you numbers. You know, he gave you this and say, okay, solve for W. Right? If you still need this example, guys, make up the numbers. D, what does it look like? Okay, so replace it with 9. What does K look like? A 6. Great, replace it with a 6. As long as those two aren't the same numbers because they're two different letters, you're okay. Okay, so put the 6 in the 9, or 9 in the 6, and now do this part, and then come over here and mimic those steps. You're good to go, right? Some of you guys can see the difference and saying, you know what? D and K is just numbers. I'm good. Some of you guys can't convert. You're like glitching out right now, right? Then put numbers in so you don't glitch out. Any other questions? Is someone going to ask about number 7? And 8. And don't forget, when it asks for substitution, make sure you do show substitution. If it says elimination, make sure you show elimination. And remember, my goal for your lab work is the fact that you're already done by now when you leave class, so all you have to do is recopy and scan it and send it. So that you don't sit there going, I'm just going to email it to you because I got that too late. Right? That's the easy stuff. Any other questions? Huh? Notability. Notability, yep. Yeah. Yep.
So when I get my iPad, you'll help me.
Yeah.
My pencil's on the way.
Ladies and gentlemen, don't forget, you're off on Wednesday. Monday. You're off on Monday for MLK.
No, we're not.
And don't forget, if you guys looked at my week 3, right? If you guys went into week 3, because that's next week, it would say no school January 20th. I know. My Canvas homepage just lacks information. Nothing's ever given. I'm sorry. Lack of information. Confusing information. So, ladies and gentlemen, please have a wonderful long weekend. Please be safe. Love you guys. See you guys on Tuesday. Later. Yes.